An electrical circuit contains a capacitor. The charge on the capacitor Q at time t seconds satisfies the differential equation given. Initially Q is 1 and dq dt is 8. Use Euler's method with h is 0.1 to estimate the maximum charge on the capacitor during the first second. First of all, notice that there is a question to find the maximum charge on the capacitor during the first second. So we should consider the values for Q for a given time interval and just choose the maximum value of Q. Usually, question is just to find the value at some moment of time, but anyway, you should do absolutely the same. And since it is given to use the Euler's method, we should use the next formula. It is given in a data booklet, and it says that the next value, yn plus 1, is the current value yn plus step and multiplied by the derivative at the current moment of time or at the current point. But notice that according to the requirements of a calculator, we will use the next notation, or something on minus 1 will be used for the current value, and the next value will be described as on instead of n and n plus 1. And we should, using this formula, rewrite this formula for a given value, its q, and for its derivative dq dt. So for q, it becomes q n plus 1 is the current value qn plus step, it's 0.1 here, multiplied by the derivative dq dt at the current moment of time at point n. And the initial value q0 it's 1, and for derivative dq dt at point n plus 1, the next value, it becomes the current value dq dt at n plus 0.1 and derivative of the derivative, so it becomes the second derivative at the current moment of time, so again it's at n. And the initial value dq dt initial value is 8, and the second derivative for q we get from this equation. So the second derivative of q becomes 200 minus 5 dq dt minus 20q, and we will substitute it for this expression. And how to use a calculator to find the required values for q? We will use the next notation. U will be used for time, and un, it will be the next value, it's the current value u of n minus 1 plus 0.1, 0.1 because a step is equal to 0.1, and the initial value u mean it's 0 because time is from 0 to 1 second, and let q be denoted as v and derivative be denoted as w. So for v it becomes vn, the next value is the current value v of n minus 1 again plus step 0.1 dq dt, but according to our notation dq dt is w, so it becomes plus 0.1 multiplied by the w, but also of n minus 1, it's important. And v mean, it's the initial value of q, it's 1. And for W, W is the derivative of Q, so W of n, the next value is the current value, W of n minus 1, plus 0.1, and the second derivative of Q, and we use this expression, and it must be at the current moment of time, so it will be O n minus 1. So 0.1 multiplied by 200 minus 5 dq dt. What is dq dt? dq dt, it's W, so minus 5 W multiplied by W of n minus 1, and minus 20q. What is q? Q is V according to our notation, so minus 20 multiplied by V of n minus 1. And W mean, it's 8. It's given. And we need just enter this into our calculator. First of all, we should choose mode and choose sequence here. Then y, and you can see n mean is 1, it's always 1. Un is u of n minus 1 plus 0.1. 0.1 because h is 0.1 seconds here, and u describes time intervals. U mean is 0, it's the initial moment of time, it's 0 here. V, according to our notation, V it's Q, and V is V of n minus 1 is the current value plus 0.1 W of n minus 1, and V mean is 1, and W is the derivative of Q, and the next value it's W of n minus 1 current value plus 0.1 multiplied by 200 minus 5 W of n minus 1 minus 20 multiplied by V of n minus 1, and the initial value W mean is 8, and then just second and table. And I repeat that usually question is to find for example Q at any moment of time. So you just choose the corresponding value. But here there is a specific question. We need the maximum value of Q during the first second. So according to our notation, U it's a moment of time. So we can see that it's 0 seconds, 0.1, 0.3. Since a step is 0.1, so we can see 0, 0.1, 0.3, and so on, and we should consider up to 1 second, and we need just choose the maximum value of Q, and V is Q, so we can see that V and Q changes 1, 4, 6, 9, 11, 12.3, 12.657, and it decreases. So we can see that the maximum value is just this value, and it happens when t is 0.7. So the answer is Q maximum value is 12.7 to 3 significant figures. And that's all for this question.